Hello, welcome to the class on efficiency. So I'm Laura Lewis and welcome. So understand the concept of useful and wasted energy. It's one of our learning objectives. Number 2, calculate the efficiency for a range of appliances. Number 3, use diagrams to calculate efficiency. So I'm going to put those sort of two together in this. So if you think about a light bulb, what you have in your house, a lamp or in the ceiling, so energy transfers are happening in that all the time. But which ones are useful to us? So what's going on if it's plugged in? Electrical is being transferred to light and thermal energy, so heat energy. But only one of those is useful to us because obviously it emits both those types of energy, but one of them is useful. So when we say about the word useful, we mean what we want it to do. So what what we want that to do. So although sometimes it's cold, you might like the fact that a light bulb produces heat, so thermal energy, but that's not its primary purpose is to produce heat, is it? It's to produce light. So in this case, for a light bulb, light is a useful one. It seems obvious in this case, but it gets a bit more complicated later on. Okay, so think about a car. So next example. So it's a petrol car, not electric. So petrol diesel, which uses fuel. So it has chemical energy, and in the engine it's burnt. So actually the engine burns it. It's converted to kinetic energy in the engine because the engine moves some pistons and it moves the wheels. So it's movement energy. Thermal energy. So anyone that's opened the car bonnet will know the engine gets very, very hot and can even overheat. And sound energy. So which one is useful to us? So think about which one is useful in a car. Okay. So as we want the car to move, kinetic energy is the useful one. So thermal and sound energy are produced, but we don't really want them. We don't want the engine to heat up. Actually, we have to cool it down actively. We don't want it to heat up. And sound energy, even though some people like the sound of some cars, is technically wasted still, because it's not going into doing what we want it to do. Actually, in some cars, they actually try and increase the sound, which actually, is not good for the fuel efficiency of the car, because it goes into waste it really. Okay, if it's noisy, it's actually wasting a lot of energy by sound. Okay, so calculating efficiency. So efficiency is useful energy out divided by total energy in times 100%. Okay, and you've got the wrong answer if your efficiency is over 100%. Nothing in the universe has got 100% efficiency. Okay, we're definitely not over it anyway as well. So if your answer is a bit off there. So this is called, often see these in the exams, this is called a Sankey diagram, named after the person who invented it. Okay, it shows us the energy transfers. So this is a light bulb. Okay, what we talked about before. So a light bulb, this is for. So 100 joules of electrical energy goes in, 20 joules comes out as light, and 80 joules comes out as thermal. Okay, a little bit of check there to remember. Okay, thermal. So the efficiency of this, so efficiency, remember from the previous slide, is useful energy out over total energy in. Okay, and then to get as a percentage, we multiply by 100%. Okay, so carrying on from that, useful was light, 20 joules divided by, you've got to be careful, it's a total, not the other one, it's total. Okay, and that would give us 0.2 times 100%. Okay, and that would be 20%. Okay, oh, just get rid of that. So 20%. Okay, the 20, so let me just write that again. So 20% efficient. Okay, so end answer, always underline the end answer, 20% efficient. So think about television, it's a bit more complicated for television. So if you put 500 joules in, okay, light is converted to light, sound, and thermal. So which ones are useful to us there? Okay, so useful, it's actually light and sound, because we want to be able to hear the television. So wasted is actually thermal. Okay, wasted is thermal. So again, efficiency, okay, is useful energy out over total energy in And we're going to times it by 100%, okay, to get percentage. Let's write that out properly. Useful energy out, right, so it's 250 plus 200 joules, okay. The wasted was 50, okay. So that's over the total 500. So 450 joules divided by 500 joules. Okay, and then we're going to times it by 100%. So 450 divided by 500. Okay, we're going to get 0.9 times 100%, 90%. We're going to get, so 90% efficient. Okay, so that's how you work out efficiency. So thank you for joining the class. I hope to see you in another lesson.